So at x equals 0, whoops, sorry. This had an odd multiplicity. And that was because the graph passes through the point. That was at 0, 0. But remember my when I'm writing zeros, we're writing it as x equals the number. Okay? What are your thoughts about x equals 2? Look at your graph. What's happening there? So what kind of multiplicity does it have? Yeah.
Is it also odd multiplicity?
Yeah. Because
The graph is passing through the point.
all right, just copy and paste. Now it says determine the multiplicity. So I can actually figure out what each of these multiplicities is. Remember, I told you that this was a 4th degree polynomial or a quartic polynomial, where the highest degree of your variable, the highest exponent, was going to be 4. So think about it. What's an even number, an odd number, and another odd number that could add up to 4? Because these multiplicities, the degrees of these zeros separately have to add up to 4. So do you have any thoughts about that, Luna?
Wait, would it be 2 and then 1?
Right. Because 2 plus 1 adds up to 4. And I know that even numbers are 2, 4, 6, but like that's not possible. Anything other than 2, right? And then your odd multiplicities, they could be 1, 3, 5. But if I'm going to add to 4, because the degree was 4, I want it to be 1. So the multiplicity here is actually 2. The multiplicity here is 1. And then the multiplicity for that one is 1. So that's going to help us. I know this isn't part of the directions, but that's going to help us write a possible equation. In factored form. Do you remember what we did with those zeros, what we did with those numbers when we put it in factored form? Factored form looks like this. Like x plus something, x minus something. What did I do with -2, 0, and 2 when I put it in factored form? We did like the opposite of it, where I gave you the equation and you figured out what the zeros or the x-intercepts might be. What did you do with the sign of it, Lizzie? Switch the sign. So my equation, instead of x minus 2 for this first one, what should you use? Okay, and if that has a degree of 2, I'm going to square it. Right? The next 0 is 0. X plus 0, you could do x minus 0, it's the same thing. And then the last 0 was positive 2, so when I write it as a factor, I want to write x minus 2. No, I don't think I named this function. No. So there you go. That's a possible polynomial. Now you might see it written like this. Those are the same thing, and that's probably how you'll see it written, right? Because x plus 0 is just x, okay? So remember, anything with a variable helps you find your zeros or your x-intercepts. So if this coefficient in front, where the x was just a number without a variable, that wouldn't affect your zeros. But since it's a variable, we want it to be one of our zeros or one of our x-intercepts. Are you with me? Yeah? Okay, do we feel okay about that? All right, let's move on. Here's the next example. The directions change. So I want you to highlight this, the first couple of words. It says, give the x-intercepts. How is this different than the last one? Because I asked you to give the zeros in the last problem, right? They were written as x equals a number. These x-intercepts now have to be written as ordered pairs, okay? You're also going to tell the multiplicity of the function below and describe the behavior of the graph at each x-intercept. Then to give the degree of the function, okay? Here it is. So before I gave you the graph, now I'm giving you the equation in factored form. So you need to identify, first of all, the x-intercepts. Make sure you write them as an ordered pair. So it's going to be a number, comma, 0. What would they be? -1.
Don't we change it?
Yeah. -1, 0. We'll talk about their multiplicity in a second. Juliana?
Would it be 2, 0?
Yeah. See how I wrote them as ordered pairs now? Because they are x-intercepts. So you just take each of these factors and you change the sign. X plus 1 equals 0, so x equals a -1. X minus 2 equals 0, so x equals a +2. Same thing with the x plus 1/2. Okay? Now, what's the multiplicity of each of these? Because then that's going to tell me what happens at each of those points. Now, you were using the graph to tell whether it was even or odd and then figuring out what it was. But now since you don't have the graph, you just have to look at the degree of each factor. So what's the degree of x plus 1? You see an exponent of 2, okay? So that's the multiplicity. Multiplicity of 2. That's an even number. So what's happening on your graph? Is it passing through or is it just touching it? That was back up here.
Tangent.
It's tangent to the x-axis. That's all I need you to write. Tangent to x-axis. Do the same thing for the other two x-intercepts. Tell me the multiplicity and then say it's tangent to it or it passes through it at the x-axis. Are we okay with 2, 0 being the exact same thing? A multiplicity of 2. And then it's even, so it's tangent to the x-axis. What's the exponent with the factor x plus 1/2? 1. There's a 1 there, even though you don't see it. So that one has a multiplicity of 1. And it's not tangent to it. It's odd, so it passes through it.
Wait. So if it's odd, it's not tangent,
Exactly.
but -1 is odd.
Not the number, the degree.
Oh, okay. Okay, that makes sense.
You're right, -1 is
Yeah, I
odd.
was like confused. Sorry.
The degree. You're always using the degree, which is the multiplicity.
Okay.
Okay, so my last one says, what's the degree of the function? If you were to sit here and you were to like multiply it all out and put it in standard form, What would the highest exponent be? And how would you know that? I don't want you to do all that. Isabella,
5.
how'd you get that?
Because if you add 2 and 2 and 1.
Yeah. Just add up all your exponents. Okay? Now I will point out, I said this when we ended the last one. You had an x that was out in front of your factors. That one doesn't have an x, so that doesn't affect your zeros or your x-intercepts. It also doesn't affect your degree. It would if there was an x there. Okay, so your degree of the function is 5. You would call this a 5th degree polynomial. Okay? Do we feel okay about that? That's all you do. Okay, now the directions are going to change on the next one. Write the lowest degree polynomial function, we're going to call this one g, that has the given set of zeros and whose graph has the given y-intercept. We're going to write our answer in standard form. So we're doing a lot of what you did in day 3, day 2, where you're writing it in standard form. You're just using different information now. So here's the information that I'm going to give you. Here's your zeros. The zeros are at x equals -2, 3, and 4. But 4 has a double root. And it also has a y-intercept of 0, 192. So what are you going to do? You're going to start it off very similar to what we were doing in day 2. I would take those zeros and write them as factors. I'm calling this G. I don't know if there's a leading coefficient. You got to find that. How would you use those zeros to write it in factored form? What's that going to look like? We were just kind of doing that, or the opposite of that? I know.
X plus 2.
Good.
And parentheses, and then whatever, x minus 3.
Opposite sign. Good job.
And then x minus 4. And then I don't know what the root is.
What does that mean?
2.
Yeah. Squared. A root or a zero, like they're the same words. Okay, so I'm just saying this one's happening twice.
Okay.
You could write it out as x minus 4, because that's what it means to square something. All right? Now, do you know A?
Yeah.
Right now you do?
Oh, wait. No.
How are you going to find A? We did this on the quiz.
Use 192.
Yeah.
Put it on
You plug it in for x and then g of x. Your g of x is the same thing as y, right? Okay. So here's what that looks like. 192 equals A times 0 plus 2 times 0 minus 3 times 0 minus 4 squared. Don't forget to square that one. Now you only got one variable. You can solve. So I know this is what? -6 times a positive 16. Is that 96? -96? Yeah, okay. Divide by a -96. A equals 2. -2. Good answer. Okay, so now what? The directions say write it in standard form. So I want you to copy and paste. Mine's in pink. I want you to copy and paste this, but now you know A. A is -2. So now you just start multiplying. Now, here's what I would do. I would focus on like x plus 2 times x minus 3, and I would FOIL those two first. So x plus 2 times x minus 3, what do we get? X squared minus x minus 6. And then what's x minus 4 times x minus 4? Just be careful about this. Because when you see this, you're going to want to do x squared plus 16. Not a thing. X minus 4 times x minus 4, Juliana.
Would it be x squared minus 8x plus 16?
There you go. Now, you could multiply the -2 by that first trinomial, but remember I said it's probably easiest if you wait and do it at the end. So, draw yourself 3 by 3 rectangle. You don't have to use the rectangle, but with a trinomial times a trinomial, it might be a better way for you to organize your thoughts. So remember, we're just multiplying columns and the rows and putting the product in each of those boxes. Whoa. I would recommend using a highlighter to highlight your like terms because we have a couple of them here. Double check my mental math there. Kind of questionable on a Monday morning. I meant to do these in a different color, sorry. Okay, now the only thing left to do would be to distribute that -2. What part did I get wrong?
The -64 as 48 would be positive because it's
It is a positive. So, 32? Positive 32. Thank you, Kara. All right, multiply by a -2. Don't forget the negative part of it. So, -2x to the 4th plus 18x to the 3rd minus 36x squared minus 64x plus, what is that, 192? And that is your final answer. Now, some of them, I'll give you the leading coefficient. So guess what? You don't have to do any of this. If you know the leading coefficient, you can just come up with this factored form and then just start multiplying. Are you with me? If you don't know a leading coefficient and you know a point that it passes through, this one I specifically gave you was a y-intercept, but it could be any random point. You got to find the leading coefficient and then multiply. Are you with me? Okay, so now I need to go up and finish the rest of our notes, like the fill-in parts. Okay? So I didn't talk about conjugates with you because the next few examples, this is when we're using it. Okay? So first of all, what is a conjugate? So something like this. Those are conjugates of each other. Because one has a positive sign and one has a negative sign. A plus radical b, a minus radical b. Okay? When we multiply this, we are going to get a rational number. Okay? So if I were to FOIL a plus radical b and a minus radical b, I want to show you what that looks like. If you FOIL that, you get a times a squared. Your outers become negative a radical b. Your inners become positive a radical b. And then your last become what? What's a positive radical b times a negative radical b? What do you get when you multiply two radicals that are the same? Something like radical 3 times radical 3. Isabella? Minus b, exactly. So this would be the square root of 9, but the square root of 9 is a perfect square, and it's just 3. Okay? So you are just going to get minus b. And then these things in the middle cancel out, so all you're getting is a minus b. It's going to be a much prettier number. I know that that's like super duper ugly for you right now, but the answer is going to be pretty. Okay? Where did the a squared go? Yeah, sorry, it's a squared minus b. Yes. Sorry, a squared minus b. Not b squared though. Okay, so why are we doing this? So your imaginary roots are going to come in conjugate pairs, meaning if you have like a positive bi, which is an imaginary number, as a 0 or a root that I give you, then you're also going to, it's not going to be listed, but you're also going to need to consider the negative of that. Or if I give you the negative, then you need to consider the positive, the conjugate. How come? Because when I multiply those two, it's going to give me a much prettier number, and it's going to look not imaginary anymore. Because what's I times I? What's I times I? I squared, what's I squared? -1, right. Okay. We also need to remember, I've said this like 10 times, that none of your imaginary numbers will be your x-intercepts. None of the imaginary numbers that are zeros will be x-intercepts because they are imaginary and they're not on a graph. Okay? Yep.
Sorry, did you FOIL that?
I did, yes. But I'm telling you the radicals are going away and the i's are going to go away. So it's going to be a much prettier when I use these things called conjugate pairs. Okay? You just have to change the sign. That's all I really care about. Okay? Now, here's our next example. Okay, so here's what you're doing. I'm giving you, or this information is about a third degree polynomial function. We're calling this one K. That has real coefficients, and your zeros are at 2 and 5i. Your leading coefficient is 1, which is good. That makes this a little easier. Okay? So identify the missing zero. It's a third degree polynomial. However, I only gave you 2 zeros. And that's because if I give you a 5i, what's the missing zero? That's not listed. Negative 5i. Exactly. So you have these 3 zeros now. You have 2 positive 5i and negative 5i. Whenever you see the imaginaries, they probably won't be listed both as the positive and negative. So identify your missing one, which here it would be the negative 5i. Now write this in standard form. Call your function k of x. My leading coefficient is 1. Use these zeros to write the factors, like write it in factored form. Any suggestions? My leading coefficient's 1, which is good. If x equals 2 is a 0, what's that look like in a factor, Stella?
X minus 2,
Okay.
and then would the next one be x minus 5i?
Okay.
And then would there be an x plus 5i?
Mm-hmm. You don't have to find a. I gave that to you, the leading coefficient. What do you think might be helpful to FOIL first? Because now we're writing it in standard form. Juliana? The eyes. Let's do that. First, outer, inner, last. So when you multiply your first, x times x, that's easy, x squared, right? Your outers. What do you get when you multiply your outers? Be careful. Negative, or
I squared?
it's going to be crazy. Sorry. Your outers. We're multiplying
Oh, no,
x
you're last.
times 5i. So it's just written as like 5ix or 5xi. But why did we multiply by the conjugate?
What do you mean?
Why did I multiply by the conjugate? Why do they have different signs? What happened up here when you have the same numbers with different signs in both of your binomials? Exactly. So that thing that's ugly in the middle, it's going to look ugly to you, but it's going to cancel out. Okay? So then when we do our inners, you get the minus 5ix, or xi, whatever you want. And those are the things that are going to cancel out. That's why we're doing a positive 5i and a negative 5i as my zeros. What do you get when you multiply the last?
Negative 5 minus, oh wait, negative 20.
Mm-hmm.
And then would you just put in a negative 1 there?
Yep. This is a negative 1, but remember, it's negative 25 times a negative 1. Don't add it. Don't subtract it. You're multiplying.
So can you just change it to 25?
Yeah. Doesn't that look much prettier than what we just went through? Guess what? It's always going to be that. Okay? This is always going to be the form that it's written in. It's always going to be x squared plus whatever the second parts of your binomials are, squared. Okay?
So we should never have an I in the answer.
No. Exactly. You're right. So here's what we got. We're not done yet. You don't need to write the 1 as a leading coefficient if you don't want to. If it was anything else other than a 1, you would have to write it. Can you multiply that? Yeah? Okay. Now you can just FOIL if you want, or you can use your rectangles, whatever makes you happiest. So what is this? This is x minus, oh gosh, positive x minus 2, and then positive x squared plus 25. There's actually no like terms, I don't think, right?
Would you just have to like put it in order?
Yeah, that order, we call it standard form. Highest exponent to lowest. And if there was a leading coefficient other than 1, you would distribute it after, but there wasn't, so we're done there. Yeah, thank you, Luna. Annie?
Sorry, for number 1, when you said identify the missing 0, why did you do negative 5?
Yeah, so when I give you these zeros and one of them is imaginary, I will give you one of them, whether that's the positive one or the negative one. But you need to include, thank you, the negative one or the opposite sign.
Okay.
That's the conjugate.
Okay.
And that's what we need to use in order to get me here
Okay.
without the eyes.
Okay.
Yeah. Okay, so now I want you to graph. Can you put that in your calculator? The x squared minus 2x, sorry, x to the third minus 2x squared plus 25x minus 50. Just put that in your calculator. Which x-intercept can you see? Just 2, 0, right? Which x-intercept can we see? Just 2, 0. There's no other x-intercepts, right, Lily? No. Do you know why?
Is that also, I don't know, like the thing we did before when it's not a real number?
Yeah, it's not a what number?
A real number?
Right, we call them, what's the I mean? Imaginary? Yeah. You are only going to see real zeros, real numbers, as x-intercepts on your graph, okay? These other two girls, positive 5i and negative 5i, you're never going to see those on your graph. So why don't we see all 3 zeros? You can say, you will never see imaginary zeros on the graph. And in that case, this case, it was the positive 5i and the negative 5i. You're never going to see them. Oh, great. We only have one more. Okay, now this last one's a combination of the last 2 examples we just did, where you're going to have an imaginary 0, but it's passing through this point. So do you have a leading coefficient? No. You need to find it. Okay? So here we go. It's a 3rd degree polynomial. With a real coefficient, your zeros are at x equals 1 and x equals I, and it's passing through your point 2, negative 10. What's your missing 0? Negative I. Good job. You see a positive I, you need to use a negative I. Okay? Now it's going to ask us to write it in standard form. Unlike the last one, you don't have a leading coefficient. So, take your zeros. What are we calling this one? K. You don't have A, but you do know how to write 1, I, and negative I as your factors, right? What do I do to find A?
Do you have to plug y and 0, or what your x and y in?
Yes. Now don't always assume, so on that last example it was 0, a number, But you're right. You have to plug these numbers f and then call this k of x, sorry, x and k of x in there. I agree.
Where do we put the third degree? Or is that just saying?
So the third degree means at the end, you should see a highest exponent of 3.
Okay.
Yeah.
You don't have to put that in right now.
No.
At the end.
No, what that tells you is you got 3 zeros.
Okay.
1, 2, 3. You should see 3 x's in factored form. And then at the end, you should see x to the third. Yeah. Okay, what do you think I should do from here? Because this is kind of crazy. Yeah?
You foiled off.
I would. 2 plus I, those are a real and imaginary. So don't try to combine it to make it 2i. Okay? If you FOIL this and you multiply your first, you get 4. Your outers, you get a positive 2i. Remember, it's going to be pretty because those things in the middle are going to eliminate. And then I get negative I squared.
Which can you just come to the negative?
Yeah,
Would it just be 1?
it would be a positive 1 because you have a negative out in front that you're multiplying by a negative 1.
Which is 5.
4 plus 1 ends up getting you 5. Good job. I don't know why I put 15, sorry. 4, oh, got it. 4 plus 1 equals 5. I forgot my equal sign. So what do we have here? Back to it. Negative 10 equals a, 2 minus 1 is 1 times 5. 5 times 1 is 5. Is your a value going to be negative 2? Yeah. Now, take that function that you started with, but now you know a. So now you can start multiplying. What do you think I would maybe recommend you start multiplying first? Yeah, Juliana?
Which is the x plus I.
Yeah.
times I.
Yeah, I would. Now you're going to get good at this. You are now learning that you don't need to do first, outer, inner, last. When they are conjugates, you can just do first and last. Are you with me? Because your outers and your inners are going to cancel out. So here's what I have. K of x equals negative 2 times x minus 1 times x squared plus 1. I forgot my squared. You can do foiling or you can do the rectangle.
When it's x times 1, you can just put x, right?
Say that again.
When it's x times 1, you can just put x.
Yes. As long as you got your signs correct. Thank you. Also remember, my recommendation is for you to multiply the leading coefficient last. So distribute it. So there you go, Lena. Third degree polynomial, your highest exponent is 3. We also call that a cubic. Now, do I have two more questions? So, describe the behavior of the function at each zero.
Oh, is that when we're doing like the tangent?
Yes, touches or tangent and then passes through. So back up here, I would look at your factored form, right? Because then we were using like the degrees. X minus 1. What did I say? Identify, are they the zeros that we're talking about? Yeah, I gave you these zeros. So at x equals 1, that had a multiplicity of 1. So what do you say? Does it pass through or is it tangent to?
Does it pass through?
Uh-huh, because it's odd.
Wait, of one eye?
What? No, that's just 1. Yeah. So we had our zeros of 1. Okay. What did you tell me before in the last problem about positive 5i and negative 5i? If I'm asking you to describe what's happening on the graph,
There's nothing.
yeah. So, like, that's really all I need. You can put x equals I and x equals negative I are not on the graph because they are imaginary. Okay, now I'm going to take it back to section 3. What are these fill in the blanks? As the input values increase, the output values of the function what? Remember, you want to use what's happening in standard form. That's right here. Is the leading coefficient positive or negative?
Negative.
Negative. Is the degree even or odd? Odd. So remember, if it's negative and odd, the negative tells you what's happening on the right-hand side. Is it going up or down? Down. So you're going to say what? Increases or decreases? Decreases. And if it's odd, does that mean my words are the same or my words are different? Different.